Where is that intern? Oh, there you are. For today's interview, I want you to explain Model Context Protocol, or MCP. What is it and why is it used? Oh, I learned about this last week in a project. MCP was actually created by Anthropic in 2024. Now, it fixes one of the biggest problems with AI systems. Models are great at reasoning, but they can't actually do anything safely with real tools. You mean like APIs, databases, that kind of thing? Exactly. Before MCP, every company had to build their own custom integration layer. Cursor had its own way to talk to SupaBase, Claude had its own way to talk to GitHub. Everyone was writing nearly identical code again and again and again to solve the same problem. Damn, so there's no shared interface. Everyone just kept gluing stuff together by hand. Right, exactly. It was slow, it was inconsistent, it was hard to secure. And MCP changed this by building one standard, one protocol, so that AI systems could talk to real tools. All right, that makes sense, but a shared protocol sounds good in theory, but how does this actually work? What it means is instead of hard coding connections, AI hosts and tools can communicate through a common structure. Think of it like a universal API layer. There are three parts, so the AI host, those are tools like Claude or Cursor. Then we've got the MCP server, which sits in the middle. And then we've got the tools themselves, so APIs or databases or file systems. When AI needs to do something, it doesn't just call an endpoint. It sends a structured request, usually in JSON, to get exactly what it wants. The MCP server interprets it, runs the command safely, and then returns the result. So the AI is kind of sandboxed, I guess. It knows how to ask, but it doesn't know how to talk to those tools directly. Exactly, so it starts with what is called discovery. The model essentially first asks, what tools do you have? The MCP server then sends back a list with input and output schemas. The AI then tells the server what it needs and it executes the action. The cool thing about this process is that it's predictable and repeatable. I can't lie, this structure is actually cleaner than I thought it would be, but does anyone actually use this in production, or is this sort of a research experiment? It's already being used, and Cursor was one of the first real use cases. It connects to multiple MCP servers like SupaBase, GitHub, or even your own local files. So if you ask Cursor to show you your SupaBase table, it doesn't need to know how the database was configured. It just asks the SupaBase MCP server what functions exist, and then it calls the right one using the shared protocol. I guess this is why Cursor has picked up so much, because it's one system that's kind of extended itself as new servers appear. Exactly, MCP is what makes that actually possible. All right, so the functionality obviously works, but as soon as you know standards, I know from experience, that adds complexity. So what made MCP actually stick? Because it's simple and open, man. Like before MCP, every team solved the integration problem in a different way. But now when a developer builds an MCP server, it can work with any AI host that supports the protocol. You build once and it's automatically compatible. It's basically the same idea that made HTTP standard for the web. Once everyone agreed to use it, obviously we know that the web took off. That's not bad at all. So a GitHub MCP made by one team could work inside Claude or Cursor. Exactly, that is the whole point. It lets tools and AI finally speak the same language. Honestly, that's pretty impressive, but as soon as you connect this many systems, there has gotta be security concerns, right? How is it handling this? This is one of the strongest elements of the design. The AI model never directly handles the credentials. It stays on the MCP server. The model sends a request, and then the server uses its own authentication to complete the call, and then sends back the result. The AI never sees any secrets or tokens. Wait, so even if a prompt got hijacked, the model couldn't leak your API key because it never had it in the first place. Exactly, the separation between intelligence and access makes it secure. Models are great at logic, but you don't want them to have your secrets. Otherwise, who knows what secrets are going to be leaked? Keeping that wall up is going to prevent a lot from happening, but there is one thing I do want to say. No system is ever perfect. Connecting multiple systems like this, there's always going to be risks. A malicious prompt could trigger the wrong command, or a server could be misconfigured. That's why MCP servers rely on layers of defense, like validating your inputs, limited permissions, sandboxing, human intervention at each step. These things are actually important for security. I guess this is where you have to have that zero trust mindset for AI tooling, right? Everything should assume least privilege, and then we verify every step. Exactly, you need security built into the architecture and how you operate as a team instead of just patching this up later on. That's what I always tell our engineers. Look, this is sounding pretty good, but in practice, how does this work with a team? Like, does it slow things down? Does it speed things up? Talk me through that. Oh, it makes things smooth. When you're in Cursor, you could use the AI chat to run queries on your SupaBase or to edit code locally, all through the same chat window. You don't have to switch SDKs or manage tokens. The AI is going to route your commands to the correct MCP servers automatically. But I would actually specify which one you want to use just to be sure. That's useful because you get the flexibility of many tools, but with one interface. Exactly, this is one workflow that works everywhere, and this is what makes it scalable. And if new tools come online, you can just plug them in, right? Oh yeah, this is where discovery really shines. Let's say today you have SupaBase and GitHub, but tomorrow you add a monitoring MCP for Grafana. The AI does not need a code update. It just asks the MCP service what tools exist, and then it starts using them. I've got to say, Intern, this is pretty impressive. Where do you think this is all heading? Yeah, it's called modular intelligence, and the system grows with you instead of just locking you into one. I mean, the long-term goal is similar to the web, right? We can grow this massive ecosystem. Imagine this MCP hub where developers publish servers for anything. APIs, cloud systems, internal systems. You'd be able to connect anything and run it from one place. Any AI that supports MCP and can discover them can use them securely. This is going to be crazy good. And lastly, I have to ask you, where did you learn this from? I just went to learn.nextweek.org and did the SupaBase project and the MCP ones. I would definitely recommend it. I'm going to make sure every candidate does this project before they join and gets the documentation that they can post on their LinkedIn or GitHub or their own professional website. Oh yeah, that is a game changer. I've got like 10 other interviews today. Hey, good job, intern. I might actually start paying you now. I'm never going to pay you.